Okay, so I want to talk a little bit about the capitate in particular. And I'm going to come back to the fabulous keystone arch idea. So we talked about this in the foot, but in the hand as well. The capitate, now we had several arches in the foot with different keystones. We're going to see in the hand, if we look in one particular map, one particular paradigm, that the capitate can be the keystone both lengthwise and crosswise. So this block that I'm putting in right here is considered the keystone, and it's going to lift the edges of the arch up and suspend the points so that I can take that out. So it's not held together with glue or anything. And the surface is a little slick, so if the ends were to slide apart, the arch would collapse. But assuming the ends don't slide apart, the thing that happens in a keystone arch is that pressure here is going to be distributed into either end. Right? That is the nature of a keystone arch, that this distribution of weight happens without any buttresses coming in from the outside. It's also called a catenary arch. So, so when we look at this carpal arch, the carpal tunnel, we can look at the capitate, which is the bone of the carpal at the middle finger, as being the keystone of that carpal arch transversely. And in the case of the hand, what keeps the ends from sliding apart is not friction with the earth, but that transverse carpal ligament. That's going to, so that if this were if this arch were the carpal arch and there were 15 bones in it instead of whatever, there'd be a little piece of ligament going across here, which is what keeps the ends from sliding apart, because if I knock it, push it further in, see the end slide apart, and then it's going to go, still working, because the end slid. Not because the arch didn't have its own integrity, but because the end slid wide. So in our hand, in this carpal arch, there's the potential for support for a kind of support where the arch does not have to flatten out. If we can find the capitate as the keystone of it and feel that what comes into the capitate gets distributed through the arch instead of pushing the capitate itself down into the surface.